Okay, so this is the example. So we will try to do the example. So a permanent magnet DC motor, which is fed by the DC-DC converter, which is a buck converter actually, has the following parameters. RA is 1.2 ohms and KT phi is 0.5 and KE phi is 0.5. So KT phi is meaning that it's actually the torque equation, and then this is KE phi meaning that this is for back EMF equation. So the question is, when the motor runs at speed of 1,200 RPM, rotation per minute, the torque developed by the motor is 12 Newton meter. The DC input voltage of the converter is 200 volts. So calculate the duty cycle of the converter. And the second one is more towards on the sketch, the output voltage waveform of the converter. So first, actually, let's actually draw the circuit first. So we have RA, and we assume that it is a steady state. We can ignore the inductor, LA. So this is your back EMF, EA, which is KE flux, speed of the motor. And then this is your RA. So this is your VA. So you have what you call a buck converter here. And then it is supplied by a DC source. So this is 200 volt DC source. Okay, so this is DC to DC converter. Okay, so we have the back EMF equation, and then we have also what we call torque equation. So torque equation is KT flux IA. Okay, and okay, so right now, what is the information that give is actually 1,200 RPM. So it gives you 1,200 RPM. So by looking at this, so this constant KE flux is actually in radian per second. So what you need to do is actually to convert RPM into a radian per second. So to convert into radian per second, so you need to multiply the speed with a 2 pi over 60 minutes. Okay, so this one 1,200 multiplied with 2 pi over 60. So you should get around 125.6 radian per second. So this is your speed in radian per second. Okay, and then one more thing is actually it also gives you the torque value. So torque value is given 12 Newton meter, and from this torque Newton value we can actually got the IA value. Actually, this IA, what is the value of IA that actually flow inside this motor? Okay, so your IA is actually a 12 Newton meter over your is actually 0.5. So you should get around 24 ampere. Okay, 24 ampere. So right now we have already got the speed 125.6 and IA is actually right now 24 ampere. Okay, so from here we can actually calculate your back EMF. So your back EMF EA is actually 0.5 multiplied with 125.6. Okay, so you should get around 62.8 volts. Okay, so we have already got the EA, and meaning that from that we can calculate your V armature, which is the voltage output of your DC-DC converter. So V armature is based on the equation of the KVL is simply as this one. So IA you have already got 24 multiplied with RA is given 1.2 ohm, okay, plus 62.8 volt. So you should get around 24 multiplied by 1.2. So this one should be 28.8 plus 62.8 should be 91.6. So 91.6 volts. And this is VA, and then this is your VDC. So since it's used a buck converter, so your V armature, which is your V output of the DC-DC converter, is D multiplied with your VDC. So from here you can calculate your duty cycle. 91.6 over your VDC is 200 volts. So you can actually obtain as duty cycle is 0.4, sorry, 0.458. Okay, so 0.458. So that is for the first question. So the second question, if the period of the waveform is 20 microseconds, so draw the output voltage waveform of the converter. So the output waveform. So since it's actually a DC-DC converter, so the output waveform should be in a switch. So this is your V armature. So it should be in like this, right? Pause. There is a pause. So for one period. So it said that this period is actually 20 microsecond. So right now, you need to actually calculate what is T on and what is your T off. Okay, so actually your T on is actually D multiplied with the period. So your D is 0.58 multiplied with your period is 20 microsecond. So you should got your T on is 0.458 multiplied with 20 microsecond, which is -6. You should get 91. Sorry, you should get this one 9.16 microsecond. And for this T off here is actually 20 minus 1.16, should get 10.84 microseconds. So that's all for the question number 2. Okay, so we meet again for the next example, inshallah.